Today we are talking about quadratic equations in vertex form. So yesterday we talked about them in standard form. That was y equals ax squared plus bx plus c. So before we get into vertex form, we're going to talk about a little recall with the parent function of the equation. So your parent function is your most simplified version, meaning that your coefficients are all 1, your constants are all 0. So the axis of symmetry is always x equals the number, the x value of vertex and your vertex is your value that is your minimum or your maximum. Once we have these two things, it's a lot easier to graph because we only need to come up with 2 more points, and then we can reflect our points to the other side. So your vertex form is of the form a times the quantity x minus h squared plus k. And this is a very handy form. It actually takes some of the steps that we had to do yesterday away. So I'm going to look for a second at this h method. Your axis of symmetry, if in vertex form, is always going to be along the line x equals h, meaning that my sign has to change. So whatever it is, I have to change my sign. My vertex is of the form h comma k, so my sign changes for h but not k. But basically in vertex form, you are given the vertex and the axis of symmetry. You do not have to find them like you did yesterday in standard form. So that is sort of an added bonus here. So we're going to jump right in. I have the equation x minus 3 squared plus 2. My vertex is hk. My axis of symmetry is x equals h. So remember, your equation is of the form a times x minus 3 squared plus 2. So I'm thinking that h is about a times x minus h squared plus k. So h is the opposite of the sign that you're given. So h is actually a positive 3, and k stays the same. So k is positive 2. So I have to change the sign of h, keep the sign of k. So my vertex is 3, 2. My axis of symmetry is x equals 3. So I've got my axis of symmetry. I've got my vertex at 3, 2. Now this is the part where we do the same thing we did yesterday. We're going to pick the 2 points to the right, so 4 and 5. We're going to plug them in. So I'm going to have 4 minus 3 squared plus 2. 4 minus 3, because you got to do your parentheses first. So 4 minus 3, that's 1. 1 squared is 1. 1 plus 2 is 3. So I have 1 point at 4, 3. And then I have another. I did 5 minus 3 squared plus 2. 5 minus 3 is 2. 2 squared is 4. 4 plus 6 equals, 4 plus 2 equals 6. So 5 is at 5, 6. And then just like yesterday, we're going to reflect these points across our axis of symmetry so that we have full parabola. So a lot of this is similar to yesterday. The table is similar, the graphing is similar. The only difference is today you're essentially given the vertex and axis of symmetry, where yesterday you had to find it. So if I have x plus 4 quantity squared plus 3, my vertex is going to fall at -4, +3. Remember, I changed that sign of my k value, and my axis of symmetry is going to be -4. So here's my axis of symmetry. My value is -4, 3. Then I'm going to pick two values to the right, plot my table. So I'm going to take -3, -2. -3, if I take -3 plus 4 squared plus 3. -3 plus 4 is 1. 1 squared is 1. 1 plus 3 is 4. So -3, 4. And -2 plus 4. That's 2. 2 squared is 4. Plus 3, 7. And I'm going to reflect these points to the other side. Now, just like yesterday, where if A was positive, it opened up, and if A was negative, it opened down, that's a good thing to check. So A is +1. Since it's positive, it makes sense that this opens up. Let's do example B. I actually want you to do it yourself. I'm not going to talk. I'm just going to do the work. So hit pause for me so that you can check it yourself. So should we get something like this at the end? Again, this makes sense because this is positive A value, so it should open up. On the last problem, we are going to incorporate our knowledge of the vertex into a word problem. So we throw a ball into the air. The path is made by the parabola -0.5 times the quantity x minus 20 squared plus 8. So I need to graph this. My vertex is 20, -8. Oops, positive. So if I have a graph, like this. I'll go by 5s here, and then I'll go by. So my vertex is going to fall at 20, +8, which means that my axis of symmetry is at 20. So I'm going to graph 25 and 30, and I'm actually going to use my calculator to help me. So I got that 0.5. So I'm going to take this up here and do 25 and 30. So negative 0.5 times quantity 25 minus 20 squared plus 8. I get a negative 4.5 when I do that. So that's already all the way down here. So ball is kind of going something like this. Since I'm going to be out of room, I'm going to keep going here. My goal is to determine how high the ball was. And even if your x-intercepts aren't exact, you can tell how high the ball was thrown because your vertex tells you your max. In this case, it tells you your maximum. So this is a maximum value. That means my vertex was my highest point. So that means that my ball was thrown at its highest @8 feet in the air.